So today's Optimist Day. It recognizes volunteers and the youth who support their communities in many different ways. So I know that means that we're celebrating many of you today because you all support your communities in a lot of different ways by volunteering through your PMC hours.
Things. So shout out to you. It is Optimist Day. I have what I think is a funny comic here, and we'll take just about one more minute to take attendance if you haven't already. One more minute to take attendance. Glad to see you here. Oh yeah, getting some more people in here. Glad to see you. Good morning, everyone. Good morning. If you're just joining us, please make sure to take attendance. And then we will rock it out. So we have our announcements today, and then we'll do notes in our assignment. I know some of you already got started on your notes, so appreciate you. So first announcement, we're looking for pen pals. I'm calling all nice humans. So if you consider yourself a nice human, we would really appreciate having you as a pen pal. All you would have to do is write to a little freshman that at our school that would really appreciate hearing from a junior. I'm going to drop the link here. This is for the pen pals. If you want to be a pen pal, all you have to do is write a letter. That's it. You don't even, I think it's like all digital and everything. So it's not like you have to like put it in the mail or anything. It's going to be very easy. But look at all these cute little humans, right? All these little humans, they need an older kid friend. So if you could sign up to be a pen pal, it's a very low lift. You might even make a little friend. And then they could, they won't always be freshmen. Sometimes they'll be sophomores and then they'll be a little bit better. Just kidding. I love my freshmen. So we have all these cute humans. They need pen pals. So if you want to sign up, it's super easy for them. You literally just put your name and you check that you're interested. That's it. So if you could go ahead and do that, that would be the best. Thank you. If you're interested in being a pen pal, that would be awesome. Cool. Hello, if you're just joining us, go ahead and take attendance, please. All right, I wanted to remind you of just the schedule. Y'all are in cohort B. Thank you all for being here. And then we'll be here until 9:45, and then you'll have your asynchronous time. And then if you have any questions, you can come back at 10:30. Or if that's when you have Spanish, you can come back at 11:20. We'll be here all the way until 12 p.m. today. So 10:30 to 12, you can come back and get your questions answered. And then that way you have that extra time. For our cohort, we did have a few people who were missing Tuesday's assignment. That is okay. You're not going to lose any late points by turning it in today. But if you are one of these humans, please do make sure that you turn in your work from Monday, right? So work from Monday. Ooh, I'm glad we're getting some people in here. All right. So please do make sure you turn in your work from Monday. And then I believe we are ready to jump into our notes. Before we do that, I want to start with looking at another pattern, right? When I say pattern, what I really mean is a comparison. So this is something that we know to be true, right? So the first one, we know 4x times 6x is 24x squared. Right? That's something we know to be true. And this is also true. We haven't ever done this before, but this is also true. I want you to go ahead and try to figure out, how did 4 square root 2 times 6 square root 3, how did that turn into 24 square root 6? Right? If you think you got it, If you think you know how it got there, tell me specifically. So don't just say like, oh, multiply. What did they multiply? What did they multiply? You can go ahead and direct message me. Thank you, Roxana, for your specificity. So how did we get from 4 root 2 and 6 root 3 to 24 root 6? Thank you, Wendy. I love the language you used. Awesome, Unique. Thank you. I love that. I love that comparison. I'm going to share these in just a moment. But if you can see the pattern, if you see what they did, go ahead and let me know. Put it in your words. Oops. Sorry, Unique. I sent that right back to you, but I meant to send that to everyone. My fault. All right. I'm seeing some amazing answers in the chat. Some people who really see this pattern. So the first thing that I saw was someone told me that we are multiplying, and absolutely we're multiplying here. We see that little dot here. That means multiply. And then someone told me that we're multiplying 4 times 6, and we get 24. And then we're multiplying 2 times 3, and we're getting 6. 2 times 3 is 6. Absolutely. I love that. Someone put it in a different way. They said they multiplied outside and outside and inside and inside. I love that. That's actually the language that I use to describe how to do this, right? So we multiply the outside number, the coefficient 4 and 6, to make the outside number 24. And we multiply the inside number and the inside number to make the inside number here, right? Someone noticed that the 4 and the 6 were multiplied in both problems. So we had 4 and 6 makes 24 here, and 4 and 6 makes 24 here. Mathematics doesn't change. It's awesome. It doesn't change between like when we're multiplying different types of things, right? So here we're multiplying x's, here we're multiplying radicals, but multiplication works in the same way. So today your mantra is going to be outsides with outsides, insides with insides, and then we're going to practice our simplifying skills. Okay? Outsides with outsides, insides with insides. Okay. We are going to jump into our notes here. We're going to jump into our notes. So I am going to open up our breakout rooms. If you are someone who likes to watch team video, you are welcome to jump into that breakout room now. But if you are going to stick around with me, you're just going to stay here. So you can press that ignore button, right? So there's a join button, but you can also just get rid of that. So you don't have to go into that room. Okay, so I'm going to open up this room. If you want to do team video, feel free to do that. You're going to jump into those rooms now. If you would like to do live action with me, grab a piece of paper and a pencil and let me know, are you ready to go? Do you need just a second? Do you need a minute to be ready? Tell me where you're at. And Miss Yama, I'm going to let you jump into the screen share. Y'all, I have something very exciting to let you know. Miss Yamanaka is going to teach us the first 2 parts of our multiplying radicals. Everybody give some snaps in the chat. A little round of applause. Yes. Jasmine is shouting you out, but she direct messages straight to me, all caps. Woo, Miss Yama. Miss Yama is gonna teach us how to do the first 2. So I'm very excited. Please cheer her on. and give her all the props. And if she asks a question, feel free to come off mute and answer it, or feel free to answer it in the chat. All right. Miss Yamanaka, take it away.
Cool. Can people hear me? I just want to make sure I'm audible. Awesome. Great. So like Miss Max said, with multiplication, we're going to do outsides with outsides and inside with insides. So to just write it in like a math form, this is what we have. We need to make sure that our Vatican, which is the inside, that doesn't really matter, I guess. The index is the same. So we want to make sure that we have the same index for us to multiply them together. Okay, so we're gonna try question number 1. So the first thing we check is whether the Vatican, the index is the same. So here, because both we have 2 in front of it, we can multiply them together, the inside. So I'm just gonna open the square root, and I'm gonna put 27 and 5 here. Yeah, okay, it's a little bit laggy, but I think it's working. So what you could do is you can multiply 27 by 5 and you get your product, and then you simplify from there. But the way I do it, because you have to break down eventually, so I just keep it like that and I try to break down and see what I can take out. So can someone tell me what I can break 27 into? You can come off mute. I don't know if I can get
3 and 9.
Yes, thank you. So we have 3 and 9. Can we further break this down?
3 and 3.
Yes, exactly, right? So like what we did with simplification, we're going to take out a pair of 2 because the index is 2. So we have 3, 3, 3, and a 5. So what can we take out?
The 3s.
Yes, the pair of 3, right? So this is going to come out. So our final answer would then be 3 square root. And because there's only 1 3 and 1 5 left, we have to multiply them back into the square root. So we will get 3 root 15. Good? All right. Any question before I move on to the second question? Oh, good. Okay. So with number 2, we have outsides and we have insides. And we will be able to multiply the radicals together because they have the same index of 3. And we can multiply the outside together. So let's do that. So first we do 2 times 5 on the outside. And then in the insides, because they have the same index, we can multiply them together to get this. And then we do the same way with simplification, where we take out any groups of 3s. So let's do it. Can someone help me with 9 and 9?
3.
Yeah, thank you. So we have 3 and 3. And 24 is also divisible. How?
3 and 8.
Yeah, thank you so much. 3 and 8. And then 8 is
2 and 4.
2 and 4. And 4 is just 2 and 2, right? And here, because any group of 3 you can take out, let's see what we have. Let me get a different color out. So we can take out this group of 3, and we can also take out this group of 2. So we just prop them out, right? And we will get the initial 2 times 5. And since the 3 and the 2 from the radical will come out, we'll also multiply them out. So it'll be 3 times 2. We get those from here. So our final answer would be 5 times 2 is 10. 3 times 2 is 6. And we'll get 60. You good? All right, Miss Mac, I think I'm done.
Yeah, Miss Yamanaka, can you leave it there for just a moment, just in case we had some people still taking notes? If you can zoom in on just 1 and 2, that'd
Okay.
be awesome. Y'all, one of the things that I noticed is that in number 2, I'm noticing that there's nothing left over in the radical, right? There's nothing left over. We took all the 3s, we moved them to the outside, and we took all the 2s and we moved them to the outside. And then there was nothing left over. The 9 and the 24 were completely moved to the outside. So that meant that we didn't have to write the radical again, right? So we could just have those coefficients on the outside. So that's how we ended up with 60. Do we have any questions for Miss Yamanaka? Thanks, Jasmine, for starting the party in the chat. You go ahead and give some snaps to Miss Yamanaka on her first but not last explanation of how to do some of these problems here. Yes, you're getting some party emojis, some hand claps, some woos in the chat for sure. Thank you, Miss Yama. Awesome. I can go ahead and pop in here.
Okay.
All right, team. We are going to continue. Don't pause. We're just going to switch our screens over here so we can keep going. Let me share my screen. All right, my friends. So we have one more of this type of multiplication that we are going to do. And it looks like this. It looks like this. We have -3 4th root 64 times 4th root of 8. Go ahead and write that one down. Oh man, my Instagram is blowing up. Hold on one moment. I should not be getting notifications though. That's annoying. All right, well, just ignore them. They come up. All right, so as Ms. Yamanaka was telling us, we're going to do outsides with outsides. Okay, George, go away. Insides times insides, right? Outsides with outsides, insides with insides. What is an outside number here? What is a number that is an outside number?
-3.
Yeah, -3 is absolutely an outside number. And Emiliano, if it's possible, could you come off mute and talk to us about why you also said 1?
I think it has. Well, I put a 1 because it's like the invisible 1 right next to the radical.
Yeah, this one right here, you're totally right. There is absolutely a 1 right here. That is our outside number for the 4th root of 8. The 4th root of 8. So our outside numbers are -3 and 4. You might have thought an outside number might be the number 4 here, the index 4. And the index 4 is just telling us the groups of how many, right? So it's telling us a really good clue, but it's not considered like an outside number here. So we know that there's going to be a 4 here, like that. So we're going to do outside times outside. So -3 times 1. Do we need to do -3 times 1? We know it's just -3, right? And then I have my 4th root. And just like Miss Yama was doing, I'm going to do 64 times 8. Could I multiply those into a big old number? Sure, of course I could. But then I'm just going to break them right back down into 64 and 8. So there's no reason to do that. So we'll save ourselves the writing. 64, how can I make 64? Lots of ways. How can I make 64?
8 and 8.
8 and 8, absolutely. Thank you, Roxana. 8 and 8. Thank you, Amira. Okay, now I've got a lot of 8s here. I got a lot of 8s here. How can I break them down? 4 and 2. Yes, Amira, thank you. 4 and 2, 4 and 2, 4 and 2. right? 4 and 2 all the way around. And then my 4s are breaking down. How do I break down 4s?
2 and 2.
2 and 2. Thanks, Zephyr. 2 and 2, 2 and 2, 2 and 2. Wow, we've got a whole hot mess here, right? Let's go ahead and cross out some things that don't matter to us anymore. This 8 is used up, 8 is used up, 8 is used up. The 4 is used up, 4 is used up, the 4 is used up. And we're left with a whole bunch of 2s. All right, this is fun. We've got some 2s. Since this has an index of 4, we need how many of a kind? How many of a kind since we have 4 there?
Two, two,
4 pairs.
pairs. Mm.
Wait, we have, it seems
Four
like
pairs of two.
we have, well, not 4 pairs of 2, but groups of 2, right? And how big the groups have to be is that number 4. It's kind of hard to say, right? Because we have 2s here. I think you all are thinking the right thing, but it's hard to, our language is hard. So we're gonna have 4 of a kind, 4 of, in this case, 2s, right? So we're gonna circle 4 2s all together. So I have 1, 2, 3, 4 of them. There's 1 that's going to the outside. And then I have 1, 2, 3, 4 of them. That's another set that's going to the outside. And then I have a leftover 2. A leftover 2. So I have the original -3, right? That was my original outside number. Then I have a set of 2s that was coming to the outside. And I have a set of 2s that was coming to the outside. And I have this extra 2 left over here, right? There's nothing I can do about the fact that that one doesn't have any friends. It's just hanging out. So then I would have -3 times 2 would be -6 times 2, which would be -12 fourth root of 2. And this is my simplified answer there. So our first step was outsides with outsides, insides with insides. My second step was to simplify. So we're really honing in on that simplify. That lesson we learned from Thursday is going to come out over and over and over as we're doing these problems. Okay. All right. Any questions? I'm going to pause here for a poll. How are we feeling about these ones thus far? Give me a fist of 5. How are you feeling? Fist, 0. This makes 0 sense. All the way up to 5. This makes total sense. Poll not launching. Can y'all see the poll? No, nothing yet. Weird. Let me try again. There we go. All right, tell me, how are you feeling about 1 through 3? Saw a couple early 3s popping in, couple 4s popping in. I would love for you to think right now, if you could ask me one question, if you could ask me one question and you were not scared, you were not scared to ask me this question. If you could ask me that one question about our math topic today, not about whatever, but we can talk about those things later. If you could ask me one question, I would love to know what that one question would be. I would love to answer some questions right now. I know we don't normally get to answer, or I don't normally get to answer questions. So if you have any, I would love to send merits to anyone who has questions. Would love to answer some of those. If you have a question, you can private message it to me. You can come off mute if you like to. All right. this is where we're at right now. We're sitting at some 3s, some 4s, some 5s. Lots of 3s though, so I'd love to, that's why I'd love to answer some questions. We have a 1. I appreciate you. Thank you for your honesty. So I'd love to answer some questions. I'm going to keep loving to answer those questions. I'm going to show you one more example. If you are, everybody's going to do one more question with me, right? Everybody's going to do one more question with me. And then for honors and, well, honors for this class, we're going to do 11, 12, and 13 together. Right, so 11, 12, and 13. I got some questions. I'm so excited. Okay, here we go. How is this different from number 2 since it doesn't have a radical? How was this one different from number 2, number 3? So these are each slightly different because this one has an imaginary 2 here. Remember their index. The index for a problem like this is an imaginary 2. So we make groups of 2 when we do it, right? And then over here, we have an index of 3. So we make groups of 3 when we're simplifying. Right? And then over here, we have a 4. So we're making groups of 4. Not of the number 4, but like 4 of a kind, right? 4 of a kind. Other than that, it is exactly the same process every single time. We multiply the outsides with the outsides, the insides with the insides, right? And then we simplify. It's the same process. I love that question. Thank you so much. Sending a merit to you. My second question, 2 questions. What a great day. When we simplify numbers, do we only simplify the numbers on the inside and automatically multiply the numbers on the outside, or do we have to simplify the outside too? Great question. So when we had 2 and 5 on the outside, we did 2 times 5 on the outside like that. We didn't have to do anything with those numbers except multiply them together to get 10, right? When we had here the 9 and the 24, the inside is what we have to break down, right? So we're only simplifying the numbers on the inside to see what we can take to the outside to join that 2 and 5. We'll multiply them all together. Does that answer your question? Yes, excellent. Sending a merit to you as well. Thank you. Thank you for your questions. This makes it way better. I'm sure you are also not the only one who had that question. So let's jump in here. All right. We have a kind of a scary problem. It says it's number 10. That's just because that's what it was on the video. I didn't want to throw people off who were watching the video. So here we have square root of 10 times 5 root 5 minus 2 root 2. Okay, so we have something on the outside, we have parentheses, and what does this look like? What do you think? What's your best guess on what we should have to do? We've never done this before. But we've done something similar. What is your best guess for what we should have to do?
You start with the parentheses first.
I can start with the parentheses first. Yes, PEMDAS. I like what you're thinking with PEMDAS. Can I combine 5 and 2 though? Remember back from Tuesday, am I allowed to combine 5 and 2?
No.
No, right? So, Okay, so I love that thought, Roxana, of combining these, but I'm not able to at this current moment. Not currently able to. What would you do if I gave you this problem? Brandon, you want to come off mute and tell us what you're thinking?
I'm thinking that you distribute.
What told you that maybe we were distributing?
I saw the 10 on the outside, and usually, like, the first thing I think of a lot when I see the 10, like only one number, and then numbers on the inside of the parentheses is like distributing.
Yeah, absolutely, Brandon. Thank you. So this 10, Brandon is totally right. This 10 is going to be multiplied on this number here, and the 10 is going to be multiplied on this number here. right? So 10 multiplied to the first one and to the second one. So here we go. We're gonna have square root 10 times 5 root 5. We're gonna do that first one first. Does square root 10 have a number in front of it? Does it have an outside number?
No.
No. So what's that like imaginary number that's there?
Imaginary 1.
Yeah, imaginary 1 for sure. Okay, so I have imaginary 1 here. So I'm going to do 1 times 5, which would be 5. And then on the inside, I would have 10 and 5. 10 times 5, like that. 10 times 5. So that's my first one. 1 times 5 is 5. 10 and 5 go to the inside. Now I'm going to do the same thing. Let me go ahead and erase this real fast. I did that first one in pink, and now I'm going to do the second one in green here. So I'm going to have subtraction. I still have that 1 here. So 1 times 2, 1 times 2 would be 2. And inside would have 10 times 2. 10 times 2. 10 times 2. How are we feeling thus far? Are we feeling okay? Give me a thumbs up if you're feeling okay. Jasmine's feeling good. Appreciate that. I've got at least 1 thumbs up. Feeling okay. Miliano's feeling good. Cool. All right. So I'm going to break down just like I have been breaking down. I'm going to break down my pink one. How can I break down 10?
2 and 5.
2 and 5. Perfect. 2 and 5. All right. I have no index here. What's the imaginary index if I don't have one?
Pairs of 2.
It's a 2 for sure. There's a 2. So I need a group of 2. I have 2 of a number. I have a 2, a 5, and a 5. So these 5 and 5 make a pair, and it's going to go to the outside here. It's going to go to the outside here. So I'm going to have times 5 out there. And I have the 2 left over. 2 left over. So the pink one is going to simplify. 5 times 5 would make 25. So 5 times 5. And then that 2 is left over. So I'd have square root 2 left over. All right, give me a thumbs up if you're still tracking. You're like, Miss, we did the pink one. That's good. Let's try the green one. Got a couple thumbs up. 3 thumbs up. Big day. All right. Okay, let's try the green one then. How can I break down 10? Oh, y'all already told me. 2 and 5. 2 and 5. Breaking down that 10. All right. There's no index. All right, there's no index. I think it was Roxana told me earlier that I have a 2 there, right? I'm looking for groups of 2, 2 of a kind. I see that I have 2 2s. So I'm going to take those 2s to the outside here. So I already have negative 2 times 2. So negative 2 times 2. And left over 5. Left over 5. What's negative 2 times 2?
-4.
Negative 4. Thank you. Negative 4 root 5. Right? Negative 4 square root 5. All right, now that I've simplified them, is there anything, can I combine, remember from Tuesday, am I allowed to combine square root 2 and square root 5?
No, you're not allowed.
No, I'm not allowed. They're not like terms. So this is my answer for this problem. This is my answer for this problem. we're multiplying in this number into each of these. Okay. I'm about to change my mind about something. So if you are honors, or if you're honors, listen closely to what I'm about to say. I'm going to stop our notes right here just based on timing, right? This is what we got to today. Sometimes we move a little slower. That is totally fine. I'm happy to move slower. That being said, that means I need to adjust our assignment just a little bit, right? Our assignment just a little bit. So if you are looking at our assignment is going to have the same place for your notes, right? You're still going to get 20 points or 10 points for your notes, right? So shout out to y'all. You already got 10 points. And then we have different sections here. So for this section, it said these are like basic ones, like number 1 and number 2, right? So star, 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 you're doing 4, on track, you're doing 6, honors, you're doing 6. That is still good, right? So this section is still good. You're going to keep following those directions. These ones are like number 2. Y'all can still do those. That's perfect. These ones are like that last problem that we just did together. Y'all can still do these ones. I have confidence in you. It might be a little challenging, but I have confidence in you. Honors, I am going to skip this portion. I'm going to cancel this portion from your assignment. This is not assigned. You can try them if you want to watch the video and do it for extra credit. You are welcome to, but this is no longer a part of your assignment. Okay, so I'm going to make that adjustment. Can someone who is in honors tell me which part I am cutting from your assignment today?
You're cutting the last part for us.
Yes, the very last part. Thank you, Roxana. So honors, you will have 2 less problems than you were going to have originally. You can still do option 2 if you want. Option 2 is like the problems that we are working on today. So you can still check out option 2 if you want. Honors, can I get a thumbs up if you understand what adjustment I have made to your assignment? Cool. So regular and star, 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 no changes. You're going to follow the directions the same way. Okay. For after that, you have just your checkpoint form. This is another 10 points here. And then you have optional extra credit if you want to keep working. I know some of you love that extra credit. Okay. Other than that, thank you so much for your patience, for your kindness, and for your questions. I love you. I will be here. Remember, me and Miss Yamanaka will be here at 10:30 to support you. So please do come back at 10:30 or at 11:20, depending on your Spanish class. Okay? Mwah, mwah, mwah. Have a great day. You are all done for today. Thank you all. Bye. Bye-bye. Yes, Joshua. What's up? And Miss Flores, it looks like a few people. Oh, Amira had jumped in, but I guess not. Josh Linares, did you have a question for me?